We are starting by setting up a database called inventory management using the use statement. This command tells MySQL to use the specified database for subsequent queries. Then we are creating pivot tables, categories, products, suppliers, and orders. Each table has its own set of columns with specific data types and constants. For example, the categories table has columns for category ID and name. Category ID is set as the primary key, ensuring each category has a unique identifier. After creating the tables, we are inserting some initial data into the categories table using the insert into statement. The insert into statement allows us to add rows of data into a table. Here, we are specifying the category ID and name for each category we are inserting. The insert into statement is followed by the name of the table we are inserting data into categories. We then specify the columns into which we are inserting data. The values keyword indicates the values we are inserting into the specified columns. Inside parentheses, we list the values for each row we want to insert, separated by commas. Each set of values corresponds to a single row of data in the table. Alright, now we are going to insert some data into a products table. This table holds information about the products we have in our inventory. So what is happening here? We are using the insert into statement to add rows of data into a products table. We specify the columns we are inserting data into: product ID, name, category ID, description, price, quality, and supplier ID. Then we use the values keyword to provide the actual values for each row we want to insert. Each set of values in parentheses represents a single row of data. For example, the first row represents a laptop with a product ID of 1, a name of laptop, a category ID of 1, a description describing its features, a price of 12,000, a quantity of 10 units in stock, and a supplier ID of 1. Now let's move on to a suppliers table. This table stores information about the companies or individuals supplying our products. Here, we are adding data into the suppliers table. Similar to the previous insert statement, we provide values for a supplier ID, name, contact email, and contact phone columns for each supplier. Lastly, let's insert some data into our orders table. This table keeps track of all the orders placed by our customers. Here, we are inserting rows of data into the orders table. Each row represents an order made by a customer and includes details such as order ID, order date, customer ID, and total amount. And there you have it. We successfully inserted data into our product, suppliers, and orders table, setting the stage for managing our inventory and tracking customer orders. In the SQL query, select star from products, we are retrieving all columns from the products table. This SQL query retrieves the product ID, product name from the products table, and category name from the categories table for each product by joining the product and category together on their category ID columns. Select star from supplies. The SQL query retrieves all columns from the suppliers table, displaying information about each supplier stored in the database. Then, this SQL query selects all columns from the orders table where the order date matches the date 2024-03-16, that is today's date, returning orders placed specifically on that date. This SQL query selects the order ID and total amount columns from the orders table, retrieving information about the order ID and total amount for each order stored in the database. This SQL query retrieves the product name from the products table, aliased as P, and the supplier name from the suppliers table, aliased as S, joining the tables based on the supplier ID to display the name of the supplier for each product. This SQL query selects the product name and quality columns from the products table, filtering the results to only include products with a quality less than 20. This SQL query retrieves the category name from the categories table and calculates the total number of products in each category by counting the product ID from the products table. It uses a left join to include all categories even without any products and groups the results by the category name.